Okay, today we're going to talk about 10.3, applying properties of chord. Hopefully you guys are having a good spring break. Just really quick, I apologize that the blueprint has not been posted online yet. Having some technical difficulties. Today is today is Tuesday, and so hopefully by tonight it will be posted. All right, so let's go ahead and get in. Applying the properties of chords. The first thing we need to understand is that if two chords are equal to one another, then they are the same distance, or they take up the same amount of circle. Okay? So if you look here at this particular diagram, chord BC and ED, or chord CB and DE, however you want to look at it, are two equal chords. BC is equal to 5, as given here, and DE is equal to 5 as well. Since those chords are the same, they take up the same amount of space in the circle. As a chord gets bigger, so let's say we have a chord here that I'm going to add in. Well, as the chord gets bigger, notice that it gets closer to the center of the circle. Okay, so then it takes up more space as it gets closer. And by space, we're talking about, this space here. That's the space the chord's taken up. Okay, so BC and DE are the same length, so their chords are congruent or equal. And therefore, if their chords are congruent and equal, then their corresponding arcs are also congruent. So in this case here, we're looking at arc BC and arc DE right there. So they are both congruent as well. So if the chords are the same, the arcs stay equal. And again, just remember, as the chord gets longer, it gets closer to the center of the circle. So you might write those things down, okay, as important information. So as the chord gets longer, it gets closer to the center of the circle. Okay? All right. So here we're given two chords, JK and chord KI, and they are both given as congruent, both equaling 7 centimeters. So if I know the measure of arc JK is 84 degrees, what is the measure of arc KI? That's right, it's also 84 degrees. Because the chords are congruent, then their arc measures are congruent. Okay? What if I pose a different problem? What if I tell you that major arc, because those are minor arcs, what if major arc JLI, so JLI, remember that middle term, some of you guys struggled this on your quiz on Friday before spring break, that middle term, that L tells us a direction, so we're going from J through L to I. So if JLI is 150 degrees, okay, then what is JK? And again, we're not using this problem anymore. So what is the mark of JK? Okay, well, it's very simple to figure out. All you'd have to do is take 360 degrees, which is your total arc, right? Total circle, minus 150. Okay? That leaves you with 210 degrees. Well, that's 210 degrees that are supposed to be left between two remaining arcs, this arc here and this arc here. Well, because these arcs are still congruent, based on our diagram, we know that they're equal. These chords are congruent. Since we know the chords are congruent, then the arcs are also congruent. So then I'm going to take that 210 and divide it by 2. and that's going to give me that arc JK and KI for that matter are 105 degrees. Okay, as always, if you have any questions, please write them down in your notes and bring them with you to class for tutoring, or you can always email me at misdgeometry@gmail.com. All right, let's move on. Okay, now this is kind of complicated, so I want you to listen carefully, and if you need to, pause, rewind, and go back and hear it again. But if a chord is a perpendicular bisector of another, okay? So tell me what's happening when you have a perpendicular bisector. Okay? You should be able to tell me that if you have a perpendicular bisector, you have 90-degree angles formed and two congruent segments. All right? So if a chord is a perpendicular bisector, if it creates a 90-degree angle and it cuts a segment in half, or a chord in half, okay, the first chord is the diameter. So let's take a look at our diagram here. So if you have this chord here, and it perpendicularly bisects this chord here, okay, then you can now say that that pink chord is the diameter. Because what's going to happen is this is a right angle, and these two sides are congruent. So that makes the pink chord the diameter. Now, also, if a segment from the center intersects a chord, then it is a perpendicular bisector. So if this segment here, PM, intersects with this chord, ON, what you're going to create now is a perpendicular bisector. And that's happening because it's a segment coming from the center. That's key right there. Segment from the center. If the segment from the center, even if it's just that little orange segment, if it's a segment from the center, it is going to perpendicularly bisect a chord, no matter what. And then finally, if the chord is bisected, then the arc is also bisected. So if you go back to this, diameter being right here that we figured out earlier, and it bisects that chord ON, that means that this arc is also being bisected, which means that arc OU is congruent to arc UN. Okay, so there's a lot of information there. I encourage you, if you didn't catch it all the first time, to go back, listen to this video again, and make sure you're writing this information down. Okay, let's extend this. If I know that MP, that's this little segment here, is 3 centimeters, and MO, this segment here, is 4 centimeters, how can I find the radius of this circle? So I want the radius. Okay, well, remember, a radius is a chord or a segment coming from the center. And no matter where you go, it'll be the same every time. So I could go there. I could go here. I know it's a little off. I'm human. But I could also go right here. if I go there, what do you notice? Well, first of all, you should understand that MP is perpendicularly bisecting ON. Therefore, this is a right angle, and it makes this a right angle. Okay, so now you have a right triangle. You know that this segment here is 3. MO is 4. How does that help us? Well, if MO is 4, that means MN is also 4. And so now you have a right triangle with the 2 legs. So you could use Pythagorean theorem, 3 squared plus 4 squared to equal PQ, and that would be your radius. And hopefully some of you learned that that special right triangle is always 3, 4, 5. So then the radius is equal to 5 centimeters. So essentially what I did is I created a right triangle out of my chord and my diameter, or my segment bisector that came from the center, and that's how I came up with a right triangle. Then I had a right triangle with given side lengths or given leg lengths, so I was able to use the rest to do Pythagorean theorem to figure out what the unknown side is, and that hypotenuse ended up being my radius. All right. One more example. Again, how can I find the radius in this particular thing here? Well, first of all, we're not given any lengths of anything right now. The only thing that we can understand is that chord BA is congruent to this chord here. How do we know that? Okay, hopefully you answered that you know that these chords are congruent because you see that these arcs have the congruent markings. And since the arcs are congruent, the chords are congruent. Well, if that's the case, then you know that these segments here are congruent because chords that are equal are the same length from the center, same distance from the center. So chords that are congruent are the same distance from the center. Since chords that are congruent are the same distance from the center, I can at least solve for x simply by putting x simply by putting 5x minus 9 equal to 2x. And you solve this, you end up with 3x equals 9. So you end up with x is equal to 3. Okay, so now if I plug x back in there, I know that this segment here is 5 times 3, which is 15, minus 9, which is 6. And 2 times 3 is equal to 6 as well. So I know those segments are now equal to 6. Okay? If I give you the radius of the circle AB, I'm sorry, not the radius. If I give you the chord length, AB is equal to 16, now we can find the radius. So AB, the whole thing is equal to 16. So what does this segment equal? What do these segments equal? 8, right? How do I know they both equal 8? Again, it goes back to what we talked about over here. If a segment from the center intersects a chord, it is a perpendicular bisector. So I know that this now is a 90-degree angle. These are congruent segments, and if it was 16 that was given, half of 16 is 8, the other half is 8. And so now all I have to do is draw a line there. And again, I have a right triangle. And so you have a leg equal to 6. Another leg equal to 8. And now you can solve for the radius. Now, again, using our skill and our knowledge, what can you tell me about 6 and 8? Well, if I divide them by 2, I end up with 3 and 4. And if I have a 3, 4, 5 triangle, and I multiply this by 2, I end up with 6, 8, 10. So my radius is going to equal 10 units. And again, that's just me understanding, and hopefully you understanding how to use special right triangles, 3, 4, 5. This is the 6, 8, 10 is a multiple of 3, 4, 5. And so if you can understand that, it's a little quicker than using Pythagorean theorem. But if you need to use Pythagorean theorem, please do that to solve. But I just figured out that the radius was 10 units. All right, so make sure you watch this, take good notes, and we will be ready to go when we come back on Monday. Have a great rest of your spring break.